Okay, so this one is section 3.2. This is going to be notes on imaginary numbers and then the quadratic formula. So for imaginary numbers, we have what we call the imaginary unit I. So if you ever see an italicized I in a math problem, that means it is equal to the square root of -1. So before in Algebra 1 and geometry, if you got a negative under the square root, you would write no real solution or no solution. Now we're going to go into the numbers that are called imaginary. So we are going to actually be solving problems with negatives underneath the square root. The ones that are really important that you know is that I equals the square root of -1. And then when we have I squared, you are going to be expected to simplify that in a problem. And that is equivalent or equal to -1. So these two things are very important to know for simplifying expressions with imaginary numbers. The reason I squared is equal to -1 is because we know that I is equal to the square root of -1. So when we take the square root of -1 times the square root of -1, anytime you take a square root multiplied by the exact same square root, it's just equal to what's under that square root sign. So that is where the -1 comes from. Next, we have what's called a complex number, and a complex number has a real part and then an imaginary part. So an example of that would be like 4 plus 3i. The 4 is the real part. It's just an ordinary number that we have been working with before, so that's real. And then the 3i is the imaginary part. And then them together is what makes one complex number. Then when you are simplifying, you need to make sure you are writing it in standard form for complex numbers. When you write a number in standard form, the real part needs to be, the real part is first, and then the imaginary part is second. That way, all of the answers should be written in the exact same format once you are done simplifying. So your real part, and that's represented by, and then your imaginary part, where we would have a number in front of I, or just. So standard form, once you're done simplifying, make sure real is before imaginary. Okay, and we've already kind of talked about this, imaginary numbers. That is when you have this, where you have a real part and an imaginary part. And don't forget, this is considered one number or one imaginary number. Awesome. Okay, so there's all the vocabulary that we will need for this page of notes. Now we're going to go through some examples where we simplify radicals where we have a negative underneath. So anytime you see a negative underneath the square root, I want you to think about it as the square root of -1 and then the square root of the remaining number. In this one, we already know that the square root of 16 is 4. And we just talked about how when we see the square root of -1, that is going to be equal to I. Once we get this simplified, then you would just write your final answer as 4i. The only thing that's changing with our simplifying radicals is if it's a negative, we add an I to our answer. That's the only thing we're adding with our radicals. So if we look to letter B, this one we have -64 that we are taking the square root of. So I'm going to separate it into a 64 and a -1, and then simplify each of those square roots. The square root of -1 is I. We already talked about that one. And then 64, that would have the square root of 8. So when we write our final answer, we would write it as 8i. When you have a whole number and then an I that goes with it, we're going to write it the same way we would write like 8x or 4x, with the number in front and then the I or the variable behind that number. Okay, our next one, so the first two were perfect squares. This one we have 18 and -1. We do know that the square root of -1 is I, but 18 is not a perfect square, so we will have to do our factor tree and simplify that. So remember, when you're simplifying, you're looking for two numbers that are the same. Oh, that's not right. 3 and 3. That. So once we do the factor tree for 18, we start with 9 and 2, and then 9 factors into 3 and 3. We're only looking at the numbers at the end of our branches. That's what we are needing to simplify. So we have a pair of 3s that can go outside of the square root, and then the 2 doesn't have a pair, that is underneath the square root when we write our final answer. When you have a problem like this, where the two parts of the answer are I and then a number with a square root, you are going to include the I in front of that radical sign. And the reason I recommend doing that, 3i square roots of 2, is if you were to put 3 square roots of 2 and I, it's really hard to tell if that I is underneath that square root or not. And we want to make sure it's not underneath that square root. So we don't want to write it this way because you might lose points because it looks like the I is underneath the square root, which would be a wrong answer. So anything out of the square root goes in front. Anything left in the square root goes underneath it. Okay, if you are struggling with that or you need extra help, make sure you are asking for more practice, and we can get that covered before the test or quiz that's coming up. Okay. Next, we are going to simplify expressions, and we're going to write our answer in standard form. When you're simplifying these expressions, I know thinking of imaginary numbers can sometimes be overwhelming, but for the most part, we're going to treat it the exact same way we would treat an x. The only thing we need to pay attention to is if we get an I squared, we need to make sure we replace that with a -1. That's the only thing that's different. Otherwise, we're going to treat it exactly how we would with a variable. So if we look at our first example for 2, we have 5 plus I in parentheses plus 1 minus -2i in parentheses. When you have this, don't forget you are technically distributing here. So we're taking that -1 and we're multiplying it by both of those parts. There's nothing other than a 1 in front of this, so that's not going to change this. So we can rewrite it without the parentheses. Then it's just the matter of combining like terms. So we're going to combine the real parts, 5 plus 1, which is 6. And then we're going to combine the imaginary parts, or I minus 2i, which is equal to -1i. Remember, you want to write your answer with the real part first and then the imaginary part after. Okay, that's it for that problem. We're going to kind of go out of order. We're going to go to letter D next and simplify this. It's very similar to what we just did on the last one. So we have some parentheses that we want to get rid of. This first one, we have a -1 that we need to distribute. And then the second set of parentheses, we have a +1 that needs to be distributed. This 3 in front, there's nothing happening with that, so that's just going to come down with our simplified answer. And once we distribute that -1, we would get -7 minus 8i, and then distribute the +1 plus 5 minus 6i. And just like before, it's combining your like terms. So we're not going to combine the reals and the imaginary. We're only going to add together the real parts. So we have 3 minus 7, which is -4, and then plus 5. And that's going to equal +1. One thing I did forget to mention, this part of the test did get moved to the no calculator part. That was a change made after we did unit 3.1, so I'm sorry that we have this little unexpected change. But it should be stuff that you know how to do from Algebra 1. And if you struggle with adding and subtracting integers or multiplying them without a calculator, make sure, again, you reach out and I can help you with those to get that figured out before we take the test. All right, So then next we have negative 8i minus 6i, and that's going to be equal to negative 14i. Now that we've combined them all, we are good to go. This problem is done. Okay. The next part that we're going to look at is letter B. This is a very commonly missed problem because of the squared. You cannot just distribute the squared to each part. That is not correct. Remember, squared means you're taking the base multiplied by itself. So we are taking this base of 1 minus 4i, and we are going to multiply that by itself, 1 minus 4i. Once you have this, you are going to FOIL. So you're going to take this first term and multiply it by the first term here. So 1 times 1 is 1. Then we're going to take the outside term, so 1 times negative 4i. Don't forget to include that negative. Oops. Then we're going to take the inside terms, another negative 4i times 1. And then the last terms, negative 4i times negative 4i. When you have a real and an imaginary part, when you're multiplying, you're going to multiply the real parts together. So negative 4 times negative 4, which would become positive 16. And then you're going to have I times I. And anytime you have I times I, that is equal to I squared. So this would become 16i squared. After you FOIL, then you're going to simplify as much as possible. So these two terms in the middle, negative 4i minus 4i, we are going to get negative 8i. And we should know that I squared is equal to negative 1. So anytime you see that I squared, we're going to replace it with a negative 1. And we're multiplying that by 16. So we have 1 minus 8i minus 16. Then we're able to combine our real parts here to get negative 15 minus 8i. Now that we don't have any I squareds, we only have one real part and one imaginary part. That means we are done simplifying this problem. Okay, so then we're going to jump over to letter E. So this one, if you want to pause and try on your own, you can. This one, again, you are FOILing and then simplifying as much as possible. Okay. When we FOIL, we're going to take 4 times 4 to get 16, 4 times 5i to get plus 20i. Then we have negative 5i times 4, which would be negative 20i. And then we would have negative 5i times positive 5i. So we're going to start by multiplying together the real parts. Negative 5 times 5. That will give us negative 25. And I times I is I squared. For this one, we end up with positive 20i minus 20i equaling 0. So those two middle terms cancel each other out to equal 0. So then we are left with 16 minus 25. And don't forget, when you have I squared, that is equal to negative 1. So then here we have two negatives that are being multiplied by together. So negative 25, negative 1. That's going to become a positive. So 16 plus 25. And once we add those, we get our final answer of 41. Okay. One thing that I want to point out about this, because we are going to use problems like this a lot, especially when we are simplifying the fraction problems, between these two sets of parentheses at the beginning, they had the same real value. And then their imaginary numbers, or the imaginary parts, they were the same, just opposite signs in front of them. Every time that happens and you FOIL it out and simplify, you are going to end up with a real number. And that's going to be useful for our example C. For example C, we have a fraction. And when you have fractions, just like with square roots, imaginary parts cannot be left in the denominator. So we are going to get rid of them by multiplying by something that's called a conjugate. These two from example E, they were considered conjugates because they had the exact same real part again, and then the imaginary part was just the opposite sign in front of it. So if we look at the bottom, we have 1 plus I. we want to find the conjugate, so we're going to keep the same real part, same imaginary part, just change the sign. So it becomes 1 minus I. When you multiply by a fraction, if it is not an equation, you have to multiply both the top and the bottom by the exact same thing. And because this top term over here has two terms, we're going to put parentheses around there because it means we are going to have to FOIL. Okay. Once we FOIL this out, the bottom part of the fraction, because these two are conjugates, or that sign in the middle is the opposite, it should simplify to a whole number without an imaginary part. If you don't get that, that means you made a mistake and you need to go back and check your math. Okay, so let's FOIL the top part. We have 6 times 1, and that'll give us 6. 6 times negative I minus 6I. And then negative 4I times 1, which would be negative 4I. And then negative 4I times negative I. So the negative 4 times the negative becomes positive 4. I times I is I squared. Yeah. Then we can FOIL the bottom part. On the bottom, we'll have 1 times 1. Oops. 1 times negative I times 1. And I times negative I, which would be minus I squared. Okay. Once you have FOILed, then you're going to look at anything you can simplify. So over here, we have negative 6I minus 4I. I know I can combine those because they're both imaginary, and that's going to be switched to negative 10I. And this I squared, I know can be switched to a negative 1. So on the top, we would end up with 6 minus 10I, and then the 4 times negative 1 would be minus 4. Then on the bottom, we have negative I plus I. Every time you do a problem like this, these two middle terms should be opposite values so that they cancel each other out to equal 0. And then this I squared at the end, I know also is a negative 1. Make sure you are being careful down here because now you have a double negative, and that is where a lot of people make a mistake on these types of problems. So the top, we know we can simplify by combining these two terms, and that would equal 2 minus 10I. On the bottom, when you're subtracting a negative, don't forget that becomes adding a positive, so it becomes 2. Now, in the directions, they want us to write this in standard form. For standard form, you need one real part, one imaginary part. So when you have a fraction like this, we have to split it up. So we're going to split it up, and both of them are going to have the exact same denominator. So we would have 2 over 2, and then minus the 10I over 2. When you split them up, you are also expected to simplify the fractions if possible. So if we look 2 over 2, you should know that equals 1 minus, and then 10I over 2, 10 divided by 2 is 5. So that would give us our final answer of 1 minus 5I. We're going to do one more example like this before we move on to the quadratic formula. I would recommend, after we go over the conjugate, FOILing it out and simplifying, and then checking your answer with the video. That way you know if you need to ask more questions before you move on to the homework. Okay, so for letter F, we cannot leave the imaginary part in the denominator. So first we're going to figure out what do we need to multiply both the top and the bottom by. We're going to look at what's in the denominator. So the 2 and the I, we're going to keep those. The only thing we're switching is the sign. So before it was a negative, now we need to change it to a plus. We have to multiply the top part of the fraction, or the numerator, by that same value to keep it equivalent. Once we do that, then you should have FOILed. So 3 times 2 would be 6. 3 times I would be plus 3I. 2I times 2 would be plus 4I. And 2I times I would be plus 2I squared. So that's our numerator. For our denominator, the bottom, 2 times 2 is 4. 2 times I is plus 2I. negative I times minus I, and negative I times I would be minus I squared. Once we have that, then we can simplify. So on the top, we have a positive 3i, positive 4i. That's going to simplify to 7i. And this I squared we know is going to be replaced with a negative 1. Same thing on the bottom. I squared is negative 1. Positive 2i, negative 2i, those cancel each other out because they're the same number but opposite signs. So that equals 0. And then we can rewrite it to see if we can simplify further. So we would have 6 plus 7i and 2 times negative 1 at the end, 2. And then we would have 4. On the top, we still need to combine those real parts. So 6 minus 2 would be 4 plus 7i. On the bottom, the denominator, 4 plus 1, that would equal 5. Don't forget, again, in standard form, we need one real part, one imaginary part. So we're going to write one fraction with the real part over the denominator and one fraction with the imaginary part over the denominator. This sign on the top should be what's in between your two fractions. So because that's a plus, we should be adding our fractions. So this would be equal to 4 over 5 plus 7i over 5. These fractions can't be simplified, meaning that is our final answer. If you have any questions on this first page, make sure you let me know. The next video will go over quadratic formula.